Hello all. Let's begin our class. I already updated the course website, so you can check the quiz results of the previous week. And I also updated the accuracy results of assignment 3. And the deadline is today at 12 o'clock p.m. I think most students get 100 accuracy. And I also updated the results of assignment 4. If your accuracy is -1, means the C++ compiler cannot compile your file. So, and accuracy of -2 means the output format is not is incorrect. And this might due to the following reasons. You might send the wrong file, or you use the wrong link. For example, you want to send assignment 4, but you click the link for assignment 3. So you send assignment 3. So this will cause the evaluation program cannot evaluate your assignment properly. So I always suggest double check your sent folder, and it is a good practice. And many students got -2. This is because they didn't follow the instructions. And you can read the instructions of assignment 4. Here I emphasize do not modify the two functions. Do not modify, this function is to deal with user inputs. And this function is to display the program outputs. And the two functions are provided by the code template. And if you modify the two functions, this will cause the evaluation program not being able to judge your program correctly. For example, I see some students for example, I saw some students modify the statement like this. He added a line break here. This will cause one additional line break in output, and this is not required by the requirement of this assignment. So do not modify any C in C out statements in the code template. And you might observe here is a line break after this column. This line break is entered by the user. So this line break is not produced by the program. So you cannot output a line break here. You should follow the code template. And if your accuracy is not 100%, then you can you should test all the input-output samples. You can copy the inputs of this example and to see whether your program outputs match the outputs shown here. And next week, I will announce the final assignment. Next week, I will announce assignment 5. This week, we will learn vectors. We will finish this chapter. Vectors are like dynamic arrays, which means you can grow or shrink a vector. This is different from a static vector. For a static vector, you cannot adjust its size. But for vectors are like dynamic arrays. You are allowed to adjust its size. Here is this figure shows some member functions of a vector. You can use size. You can use the member function size to obtain the size of a vector. And the size means the number of elements in this vector. We also have the capacity member function. Capacity means the number of allocated memory space for this container. And the capacity is always greater than or equal to size. Here I will use one example to demonstrate how to use vector. For example, if you initialize, if you declare a vector but without initialization, then its size is 0 because this vector contains no elements. So we see its size is 0. Then you can perform some. You can add elements to this vector. For example, I want to add one element to this vector. Then I can use the pushback function. And after pushback, the size is increased by 1. So you see after the pushback function call, the size of scores is increased by 1. However, you cannot use use brackets. However, you cannot use these statements because its size is 0. If you use brackets, this will not increase its size. I suggest to use the at function because at function can detect index out of range. For example, if you try to assign 1 to this element to the first element in the vector, this will cause index out of range because the size of scores is 0, so you cannot access it. So this vector has no elements, and therefore you cannot assign some value to its element. So if you want to adjust, if you want to increase the size of a vector, you should use pushback. And we also introduce other functions. For example, you can perform assignment. You can assign one vector to another. And here begin is also a member function. It's like a pointer. This member function will return an iterator pointing to the first element in this vector, and the end will return one iterator pointing to the element after the last element. The reason for this design is end minus begin end minus begin is equals to its size. So you can see that these are two pointer. You can treat you can treat iterator as a pointer, and if you perform pointer subtraction, this will result an integer. So and if you subtract begin from end, then you obtain one integer, and this integer should equal to the size of this vector. here, for example, I want to here I want to copy this vector, scores vector, to this copy variable. Then I can use this statement. This is called a constructor. And for this function call, you need to supply two iterators. The two iterators will specify the range you want to copy. For example, I want to copy the entire vector. And if you only want to copy the first three elements, then here you use begin plus 3. So if you subtract the second parameter, if you subtract the second parameter from the first parameter, you obtain 3, because 3 minus 0 is 3. So you copy the first 3 elements. And if you want to copy the last 3 elements, you can change the iterator, the arguments. For example, if I want to copy the last 3 elements, then you might use end. So the first parameter is end minus 3, and the second parameter is end. And you see that this statement will copy the last 3 elements of scores to this variable. And you can also practice how to use the insert member function. You can insert one element, or you can you can insert multiple repeated elements. For example, you want to insert 3 negative ones, then you can use this statement. Similarly, you can also erase one element or erase multiple elements from a vector. The next example shows how to shows the concepts of size and complexity for vectors. Initially, I declare a vector. This vector is empty, so its size is 0. Then we have a for loop, and inside this for loop we have an inner for loop. This inner for loop will perform pushback 500 times. So after the inner for loop, 500 elements will be added to vector. And so after the inner for loop, we print its size and print its capacity. And the following is the output. So in the first iteration, when I is 0, when I is 0, then after the inner for loop, size is adjusted to 500, because we have 500 elements, and the capacity is set to 512 Uh, this is determined by the implementation of this vector library. And we know capacity is always greater than or equal to size. So 512 is greater than 500. And in the second iteration, when I equals 1, the size becomes 1000 because we add 500 elements to this vector. And because capacity is smaller than size, or because 512 is smaller than 1000, so capacity doubles. So here capacity doubles to 1024. And in the third iteration, when I equals 2, another 500 elements are added to this vector. So its size becomes 1500. And again, we see size is greater than capacity. So 1500 is larger than 1024. So its capacity is double again. Its capacity becomes 2048. And in the fourth iteration, when I equals 3, another 5 elements is added to this vector. And this time, the size is smaller than capacity. So size is 2000, capacity is 2048. So this time, we don't need to increase the capacity. So capacity remains the same. So you can trace this. You can trace this program to understand how the size and the capacity are adjusted. Next, we will have a quiz. So if you need answer sheets, please raise your hand. Here is the first question. You need to close your laptop and the tablet until the quiz is finished. 30 seconds left. Then I will turn on the second question. Uh, 30 seconds left. And I will turn on the last question. 30 seconds left. I will close all the questions. If you use answer sheets, remember to write down your student ID and your name, and submit your answer sheets to me. Anyone use answer sheets? Let's see the answers to the quiz. For the first question, the answer is option 3. Because when you perform ampersand, if you here we prefix the ampersand operator. This means we want to obtain the address of the first element, and the memory address is a pointer. Then if you add it to a pointer, this is pointer addition. And pointer addition means when you perform +2, this means you add the memory size of 2 elements, not 2 bytes. So here 2 means the memory size of 2 elements, and each element is size of int. So here the value of PTR should be this one. PTR is a pointer. Pointer is used to store memory address. So the result, the answer is option 3. The answer to the second question is option 2. We need to compute the value of star PTR1, and PTR1 points to PTR1 points to V1. So we want to trace the value of V1, and V1 is determined by this line. So V1 equals V1 plus star PTR2. The initial value of V1 is 3, so here is 3 plus star PTR2. So we need to know the value of star PTR2. And PTR2 points to V2. So the initial value of V2 is 7. And this line performs 7 minus 5. So the value of V2 becomes 2. So here star PTR2 is 2. And the 2 plus 3 is 5. So the value of V1 is, or star PTR1 is 5. So you can trace the value of each variable. For the last question, the answer is option 2. It is a syntax error. For this one, we want to determine the value of PTR2, and you see this statement. We assign star PTR1 to PTR2, and if we want to perform assignment, the data type must match. On the right hand side is an integer, because we perform dereference. So after you perform dereference, we obtain integer. So on the right hand side is an integer, but on the left hand side is int star. The two data types are different. So the data type are different, so we cannot perform assignment. This will cause syntax error. So if you compile the switch statements, you will obtain some error message. If no further questions, then I will return to our slides. Let's return to the size and the capacity of a vector. And the next slide, next slide shows two related member functions, resize and the reserve. We can allocate memory for a vector by ourselves. For example, if you want to allocate the memory space of 100 elements, you can use reserve. And the reserve will not create instance. So after reserve, its size remains the same. Another related function is resize. Resize not only allocates memory, but also creates instance. So both reserve and resize allocates memory, but resize perform one additional task. Resize also create instance. Here we can use this example to show how to use resize and reserve. So after reserve, you can print its capacity and its size. Its size is 0 because we do not create any elements. We do not create any instance. So v1 dot size is 0, and its capacity becomes 100 because we allocated 100 elements, the memory space of 100 elements. And next, I will test resize. Here, I make a function call resize, and this will create 100 elements. So the size of V2 is 100. Its capacity is also 100. And we have finished this chapter. So we have finished vectors, and then we will move to the then we will go to the next chapter. The next chapter is about strings. And let's see the slides. In this chapter, I will introduce 3 parts. The first part is about C string. C string is the strings in the C programming language. This is actually a character array. It's static. And the second part, I will introduce C++ string. C++ string is like a vector. You can dynamic adjust its size. While for C string is like static array. Its size is fixed. The third part is about string input-output. I will introduce some functions to deal with string or character input-output. Time is up, so let's take a break for 10 minutes. Hello, let's continue our class. First, I will introduce C string. C string is a static character array. So you see that this is static array, and each element is a character. And you can initialize a C string like this. Each element is enclosed by single quotes. And we have one additional requirement for the C string. The last element must be the null character. So the last element in a C string must be the null character. The null character is \0. And actually, you can treat character as an integer. Each character has its own corresponding integer value. And this is known as ASCII value. So you can search, for example, you can search ASCII table C++. Then you can find this table. And for the null character is this one. This is the null character, \0. And its corresponding decimal value is 0. And if you search another character, for example, character A in lowercase, its decimal value is 97. If you search the character 0, its decimal value is not 0. Its decimal value is 48. So you can treat a character like an integer. And later we will see we can exploit this property. this statement declares a character array, but this character array is not a C string because its last element is not the null character. So this is not a C string. And we have you can also use another way to express a C string. We usually use double quotes. So you can use double quotes to express a C string. This is identical to the next statement. So if you use double quotes, this means this is a character array. This character array has 4 elements: character A, character B, character C, and the null character. So the 2 statements are identical. And we usually use this one because this one can save some typing. You don't need to type many single quotes. So we usually use the first one. We usually use the double quotes to express a C string. For this assignment, we do not specify array size. The array size is determined by the right-hand side. So the right-hand side will determine the array size. However, you can still specify array size. For example, if you specify array size to be 5, then its size is fixed to 5 because we know it's a static array. And on the right-hand side, we only specify 4 elements because this is equivalent to this statement. So on the right-hand side, we only specify 4 elements, and we have one remaining element not specified, and this element will be set to 0. This is according to the C++ rule. So the remaining element, the remaining unspecified element will be set to 0, and the 0 is the same as the null character because we know the decimal value of the null character is 0. So we see so the two statements are actually identical. Here we can do some experiments about C string. You can print the number of bytes of this static array. Size of this character array should return 4 because this array has 4 elements, A, B, C, and plus the null character. So if you run this program, size of will return 4. We need to you need to count the null character. And if you specify the array size, for example, if you specify 5, then size of should be 5 because its size, the number of elements is 5. And you can also test if the right-hand side is more than the left hand side. For example, we have A, B, C, D, F. So if the right hand side contains more elements than the array size, this will cause syntax error. So this will cause syntax error. This is compilation error. The compiler will show some error message. Because this static array can at most contains 5 elements, but on the right hand side contains 7 characters. So the compiler will show some error message. And actually, the size of this C string is 7. And we can try to print each character in the C string. So we can use a for loop to print each character. So here I use a for loop to print each character in this C string. So you print ABC, but we cannot see the null character because the null character is invisible, and the null character is different from a space, so we cannot see the null character. And if you want to see the null character, you can perform typecasting. You can cast character, the data type from character to integer. So we can see let's perform typecasting to from character to integer. So we see that the integer value of A is 97. The integer value of B is 98. We also see the null character. The null character is 0. So this for loop prints the 4 elements in this character array. And here we can do we can specify the array size. For example, if you specify array size to be 5, we see that this C string has 5 elements. The first 4 elements are specified by this double quote, and the remaining element is set to 0 according to the C++ rule. So in this line, we only specify the first 4 elements. We only specify A, B, C, and the null character. And the remaining element is unspecified. And it is automatically set to 0 according to the C++ rule. And we can also perform subtraction to a character. For example, you can subtract a. Here I print the value. Here I subtract a from each character. So a minus a is 0. Because and the b minus a is 1. Because b is 98 and the a is 97. And if you perform subtraction, 98 minus 97 is 1. And if you perform character C minus character A, we obtain 2. Because 99 minus 97 is 2. And you don't need to memorize its decimal value. You can use this. You can directly use this character to perform subtraction. So we don't need to memorize its decimal value is 97. You just use this character. So you don't need to rewrite A as 97. And if we want to compare two C strings, we cannot use the equality operator. Because C string is unlike built-in data type. So C string is unlike integer or double. For integer or double, we can use the equality operator to test whether two variables are the same. But for C strings are not built-in data types, so we cannot directly compare two C strings using the equality operator. We need to use the string compare function. You need to call this function to compare two C strings. And if you want to copy, if you want to assign one C string to another, we cannot use the assignment operator. You need to use the string copy function, because C string is unlike built-in data types. So you cannot use equality assignment operator to perform assignment for C strings. If you do this will cause syntax error, because we are not allowed to assign one static array to another static array. If you compile this program, you will see some error message here, this line. We cannot directly assign one. We cannot directly assign one static array to another. Even if its size is the same, you can still not perform this assignment. So we are not allowed to perform static array assignment in C++. And we need to use the string copy function. So to use this function, you need to include C-string library. C-string library is different from string library. String library is for C++ string, while C-string is the library introduced in the C programming language. So here I copy the hello C string to A string, and I need to use the string copy function. And we need to pay attention to its size, because if its size is smaller than this one, then the string we want to copy, this will cause some problem. For example, if the size is 3, you see that we have some memory problems, because this size is smaller than this C string. This C string has 6 bytes, but the size of S string is only 3. So we need to ensure its size is large enough. So using C string, you need to pay attention to array size. So here we just use the string copy. So string copy copies source into destination. And if you want to compare two strings, you can use string compare. This function will return 0 if the two strings are the same, and returns a negative value if string 1 is less than string 2, and returns a positive value if string 1 is greater than string 2. You don't need to memorize this page. You don't need to memorize this page. In the final exam, if I use these functions, I will give you its descriptions. So you don't need to memorize this page. And the next function is string length. We can use this function to obtain the string length. And this is different from array size, because string length does not include the null character. So actually string length is array size -1, because we didn't include the null character in string length. So for this, So for this example, the string length is 6, because this C string has 6 characters, and the null character is not included in the string length, and the array size is 10. So you can use this example to practice how to use string length. So let's see this example. If you print the string length is 6. For this, its size, its array size is 10, because each character is 1 byte, and we have 10 elements. So this size of will return 10. And for this statement, we do not specify its size. So its size is determined by the right hand side. The right hand side has 6 characters. So its size is 7. So this character array contains 7 bytes, because we need to include the null character. But for string length is 6. The next function is string concatenate. If you want to concatenate 2 strings, you can use the string cat. For this example, words is a C string, and I want to concate the second input to words. And to do this, we need to use the string cat. And you also need to pay attention to the capacity of the first argument. The capacity must large enough contain the concatenated string. So for C string, you need to worry about memory size. So using C string is a bit inconvenient. However, if we use C string, then you don't need to worry about this. So we prefer C string to C strings, because C string is more convenient. You don't need to worry about array size. You don't need to perform memory allocation. And C++ string support many operation, like for example, you can use assignment operator, you can use equality operator. So C++ string is more convenient than C strings. The next example shows how to implement the string length function. Suppose we want to implement this function by ourselves. This function returns an integer, and this integer is the string length, the number of characters in this string. So the input is a character array. The output is an integer. And to compute string length is easy. We just we declare index, and we check the value of in this character in this array. If its value is not the null character, then we increase index by 1. And then we proceed to the next character. And we check the value of this character. If this character is not a null character, then the while loop will continue. And if this character is equal to the null character, then the while loop terminates. And we will return the value of index when the while loop terminates. So when the while loop terminates, the index will be the position of the null character, and this value is the length, is the string length. Here we declare we add the const modifier. This is optional, but we usually include the const modifier because we didn't modify array inside this function. This can protect you to accidentally modify array inside this function. So this is a common practice. So if we do not modify the argument, we usually add the const modifier. And next, I will introduce another library, the C-type library. This library is introduced in the C programming language. And in C++, when we use the libraries from the C programming language, we usually add a prefix C. And this library contains many functions about characters. For example, we can text whether a character is in uppercase, or whether a character is a letter in the alphabet, or whether a character is a digit, or whether a character is alpha num. Alpha num means it is either a letter or a digit. Or we can test whether a character is a space. Space means space is one of the following three characters. Is either the space or the tab. Backslash T is the tab character, and backslash N is the new line character. And we can also test whether a character is punctuation. Punctuation means a printable character other than white space, digit, or a letter. For example, a comma is a punctuation. And here I wrote a program to test the functions in a CC type library. So this program demos the usage of each function. And you can download this program from our course website. You can go to the first week. You can find the reference web page. And in this page, you can go to the strings. you can go to the strings, then you can find some CPP files. You can download this CPP file. In this program, I declare a C string. I use this C string to test the functions in CC type library. So I will send each character in this string to the is alpha function. So this string is the input, is str, and inside this function I will make a function call to the second argument. The second argument is a function. So in this function call, the second argument is alpha function. So for this function call, func is alpha. Then I will send each character. To this function. So I will send h to is alpha, and print the return value of is alpha. And this for loop will process all the characters in the first argument. So the next iteration will send e to is alpha, and print the return value of is alpha. So the third iteration will send L to is alpha, and print the return value by is alpha. And the result is shown in the next page. The first line is the string to be tested, and when we send h to is alpha will return 1. 1 is non-zero value. So you see the manual here. If the input character is a non-zero, is a letter of the alphabet from A to Z, uppercase or lowercase, then this function will return a non-zero value. If the input character is not a letter, then this function will return 0. So we see that if we input h, then is alpha will return 1, and 1 is non-zero. And if you input e in lowercase, then is alpha will return 2. 2 is also non-zero. And actually, this number is according to the implementation of the is alpha of the CC type library. So this positive value depends on the library you used. And if you send a comma to is alpha, then is alpha will return 0, because comma is not a letter. And if you send white space to is alpha is also returns 0. And if you send this punctuation to character to is alpha, it also returns 0. Let's see the second function. The second function is lower. This tests whether the input character is in lowercase. If the input character is in lowercase, then this function will return a non-zero value. So if the input character is in lowercase, this function returns 2, and the 2 is non-zero. But if the input character is not in lowercase, for example, is uppercase, then this function will return 0. Its lower will return 0. Or the input character is the comma or the white space, its lower also returns 0 because it is not a letter in lowercase. And you don't need to memorize the functions in CC type library. You don't need to memorize those functions. The next slide is about the implementation of the ignore function. Suppose we want to implement this function on our own, and it's actually very simple. Suppose the input is a character. Here I use the data type is integer because we can treat a character like an integer. So this is a convention by the CC type library, and the return type is an integer. This value is 0 if the input character is not in lowercase. So we need to determine whether the input character is a letter in lowercase. And to do this, we perform the comparison. We compare CH to letter A. We can do this because each character has each character is like an integer. So here is the ASCII whole table. For example, letter A corresponds to 97. So you can compare two characters. You can compare character A and the character B. B is larger than A because the decimal value of B is 98. And the decimal value of A is 97. So we can compare two characters. So first we compare CH and the letter A. So if CH is greater than A and smaller than Z, so if CH is in this range, then C is a letter in lowercase. So then we return if this Boolean if this Boolean expression is true, then we return 2. Otherwise the input character is not in lowercase, so we return 0. For this implementation, we see that you don't need to look up the ASCII table. You don't need to know the decimal value of A and Z. So you don't need to know A is 97 and the Z is 122. You can directly use A to perform comparison. So we don't need to memorize the ASCII value of these characters. And actually, so you have two ways to check the character is between A and Z. So we have two ways. You can, so the two lines are equivalent. However, the first line is more readable because you know letter A and letter Z. And the second way is less readable because you need to look up ASCII table to know the value of 97. So the first way is better. So the first way is better. The next slide is about the implementation of its alpha function. Its input is a character, its output is an integer. And we can reuse the store function defined in the previous page. So we can reuse its store and its upper already defined in the library. So we first check whether we first make a function call to its store. We want to test whether the input character is in lowercase. If the return value is non-zero, then this means the input is is in lowercase. So we return this non-zero value. However, if the return value is 0, then we go to the else statement. So if the input is not in lowercase, then we test this. We make a function call to its upper. We test this character whether it is in uppercase, and then we return this value. If this character is in uppercase, then the return value is non-zero. And if this character is not in uppercase, its upper will return 0. So you can see that this implementation considers all the possibilities. And this implementation is also a good example of how we can reuse existing functions. The next function, the next slide shows how you can use the toLower function or the toUpper function. toLower will convert the input character from lowercase from uppercase to lowercase. So if the input character is uppercase, toLower will convert the input to lowercase. However, if the input is already a lowercase, then toLower will do nothing. So toLower will return its input. And if the input is a space, toLower also do nothing. toLower will return if the input is a space, toLower will also return a space. So you see that if the input is this C string, then toLower will convert uppercase to lowercase. And if the input is not in lowercase, then toLower will do nothing. So And similarly, we have the to upper function. To upper function will convert a character from lowercase to uppercase. So if the input is W in lowercase, the output will be W in uppercase. And if the input is already in uppercase, then to upper will return its will do nothing and return its input. I think time is up, so let's take a break for 10 minutes. Hello, let's continue our class. Previously, we see we can use islor to test whether the character is in lowercase. And this slide will show how to implement this function. So we can implement islor by ourselves. The input is a character. The output is also a character. And the first the next function is to lower. We want to convert a character to lowercase. So for this function, we want to convert the input character to lowercase. And this function only consider input character in uppercase. If input characters are not in uppercase, then we do nothing. We directly return the input character. And if input character is in uppercase, then we need to convert it to lowercase. To do this, first we perform subtraction. We subtract a. We subtract a in uppercase, and this will obtain the distance to a in uppercase. So, for example, you perform b minus a, you obtain 1. And then we need to convert this value to lowercase. So we need to perform plus a in lowercase. So you can do some experiments. And here, so here we perform character subtraction, and we know b minus a is 1. So b minus a is equivalent to you subtract the you subtract the decimal value of b from the decimal value of a. And then you can do some experiments. For example, So you can test what is a plus character A plus 1. Character A plus 1 is character B. So we see that this line prints character B. So if you want to obtain, obtain character C, then you use plus 2. You can obtain character C. And if you want to obtain and if you use plus 25, you obtain character Z. So this number is the difference, is the distance between CH and A in uppercase. So we replace this number by CH minus A. So in this way, we can convert B in uppercase to B in lowercase. Here I perform typecasting because if you don't perform typecasting, you will see the decimal values. So the input, if CH is Z in uppercase, then this expression will convert it to lowercase. And again, we see that you don't need to look up the ASCII table. You do not need to know A in uppercase is 65. You don't need to look up the ASCII table. You can directly use this character as an integer. You can directly perform addition and subtraction. We have finished the first part. We have finished the introduction to C strings. Then we will go to the second part. The second part is about C++ string. C++ string is more intuitive and easier to use. You can use C++ string as simple types. For example, you can assign one C string to a C++ string, and then you can perform string concatenation by the plus equal operator, and you can compare two strings using the equality operator. So we see. So here I use string. String is a data type. This data type is defined in string library. So I need to include this library. Then I declare a variable. So this variable is like a character array, but it is more flexible. You can directly assign one C string to this C++ string. However, if you use static array, then you cannot do this. For example, I change the data type to character array. For example, I declare a character array. Then you cannot perform this assignment. So C++ string is more intuitive and easy to use than C string. And when you want to access characters in this C++ string, we can use the brackets, or we can use the @member function. So C++ string is like a vector. For vector, we can use the function to access vector elements. So a C string is like a vector. It is a dynamic array. So we see that the first character is M. And if you try to access index out of range, for example, here I want to access element at index 6. You see that no runtime error occurs, because C++ will not give any information. However, if you use the @member function, the function can terminate your program when index out of range occurs. We see that this C++ string, its size is 4. So index is at most 3, because 4 minus 1 is 3. So index is at most 3. And however, we access the element at index 6, so we have index out of range. So if you want to access element of a C++ string, we encourage to use the function. This slide shows some common operations about C++ string. And you can use assignment. You can use assignment to initialize a C++ string, or you can use parentheses. Parentheses, this is known as a constructor. We will learn constructor in later chapters. So we will constructor is a member function of a class, and a class is a data type defined on our own. So parenthesis is a constructor. So you can also use this constructor to initialize a C++ string. And we can use the assignment operator to perform assignment. You can assign C string to a C++ string, or you can assign a C++ string to another C++ string. The next operation is string concatenation. You can concatenate two strings using the plus equal operator. And this is very convenient. You don't need to worry about the array size. This operator will automatically adjust the string size. So this operator is very convenient. Let's see this example. So here I perform I perform my string plus def string. So this plus means string concatenation. We concatenate two strings. So the result should be A, B, C, D, F. However, if both inputs, you can regard plus as a function, and this function has two inputs. If both inputs are C string, we cannot use this operation. For example, if if my string is a C string, if my string is a C string, then you cannot perform this plus, because we cannot add a C string. We can perform addition for C strings, so this will cause syntax error. So you notice that this line has some problem. Now suppose I declare another C++ string, and here I add this string. I add the C++ string in this expression. And for this line, is this line legal or illegal? If I modify the expression like this. So for this expression, we have two addition. And you can determine this expression is legal or not. Previously, we know that this expression is illegal because both operands are C string, so this is illegal. Now, if I add another CPP string here, and is this expression legal or illegal? If you think this expression is legal, please raise your hand. If you think this expression is legal. Okay, if you think this expression is illegal, please raise your hand. If you think it is illegal. Okay. Let's see let's run this program. This program, this expression is legal. It is legal, so we can see its output. Its output is 1, 2, 3, A, B, C, D, F. This is because when we carry out this expression, we need to determine which operator will be carried out first. So the leftmost operator will be carried out first because they are of the same precedence. And when you perform this addition, this addition is legal because one of the operand is a C++ string. So this expression is legal. And after you perform this expression, it will generate a C++ string. So after you carry out this expression, you obtain a C++ string. Then you perform the addition of this C++ string to a C string. And we know we can add one C++ string to a C string. So the overall expression is legal. However, the sequence is important. If you change the sequence, if you adjust the sequence, for example, if you move the CPP to the left, if you perform the first pass first, then you will have syntax error. Because the first pass is the addition of two C strings. So this is illegal. So we can see the error message here. The first addition does not support both inputs are C string. So the order is important if you want to mix use C string and C++ string. The next slide is about some functions. We already use this function. String is like a vector. So you can use the size to obtain the length of a string. And you can use the at member function to retrieve the value of one element. And you can also use length. You can also use length to obtain the length of a string. So length is the same as size. The two functions returns the same value. And the at function is similar to brackets. But we suggest the at function. The at function is better than brackets because this member function can terminate the program when index out of range occurs. But brackets will have no warnings about this index out of range. The next slide is about more functions in the C++ string library. I will skip this slide. If you are interested, you can find a manual about these functions. So I will skip this slide. The next topic is about we can convert between C string and C++ string. We can assign C string to a C++ string. This is legal. However, we cannot assign a C++ string to a C string. This is illegal. So here we assign a C string to a C++ string, but you cannot reverse this operation. You cannot assign. This will cause a syntax error if you do this. Because if we want to convert from C++ string to a C string, then you need to use a member function C underscore star. You need to use this member function, and this member function will return a C string. So if you call this member function, this member function will return a C string. So if you want to obtain a C string from a C++ string, then you need to make a function call to C underscore star. The next slide is about how to reverse a string. For example, if string is ABC, I want to reverse this string to become CBA. Then you can you can implement this function by yourself. I will skip this one. If you are interested, you can take a look. The next slide is about convert string to numbers. For example, if you want to convert string 35 to its decimal value, integer value, its integer value is 35. Then you can use STOI. STOI means string to integer. This function is defined in the C++ string library. For example, we have two C++ string, S1 and S2. And if you perform addition, this addition means string concatenation. So this is not this is not arithmetic. So when you perform plus to string data type, this means string concatenation. So we obtain 3511. And if you want to perform arithmetic, so you need to convert its data type to integer or double. So here I convert S1 to integer 35 and S2 to integer 11. So now you can perform addition. So the result should be 46. So the operator plus has different meaning for different data types. And you can use STOD string to double to convert a C string to or a C++ string to a double variable. And conversely, you can also convert a double to a C++ string. And to do this, you can use the to_string function. The next slide is about the implementation of STOI, and actually we can implement string to integer by ourselves. So the input is a C++ string. The output is the integer value of this C++ string. So our goal is to convert this string to its integer value. So the integer value of this string is 56,789. So we want to convert this string to its decimal value. And we need to understand what is, we need to understand the decimal number system. So when we write 5, 6, 7, 8, 9, this means 5 times 10 raised to 4, and plus 6 raised to 3, and so on. So you need to understand the decimal number system. And you can refer to the reference web page. You can go to the reference web page and find C++ basics, and below you can find the binary and decimal. This link will introduce binary number system and decimal number system. So if we want to obtain this integer value, first we need to obtain the decimal value of this character. So stri, when I is 0, then this is a character. This is character 5. And we need to obtain its we need to obtain its integer value. So we need to obtain 5. And if you look up the ASCII table, if you look up this table, you will find the decimal value of 5 is 53. So you cannot directly use this character as an integer, because its integer value is not 5. Its integer value is 53. So in order to obtain its integer value, so we should subtract 53 from we should perform 53 minus 48. If we perform 53 if we perform 53 minus 48, then we can obtain 5. And 48 is character 0. So if we perform this subtraction, if we perform minus character 0, then we can obtain the integer value 5. So here we perform this subtraction to obtain its integer value 5. If you do not perform this subtraction, you obtain the ASCII value. So if you do not perform this subtraction, you will obtain 53, and this is not what we want. So here we perform this subtraction, subtract character 0 to obtain the integer value 5. Then we need to multiply 10 raised to 4. And to do this, we make a function called to power. This function is defined in the math library, so you need to include the math library. And we also need to define the power. So the power is defined by the str power variable. Its value is set to, its initial value is set to string length minus 1. The string length is 5. we know that for this example, the string length is 5, and the power is 4, which is the string length minus 1. So here the initial value of string power is string length minus 1. Then we add this value to some variable, str value. Then we proceed to the next iteration. In the next iteration, we deal with the next character 6. So in the next iteration, we deal with this character 6, and we need to obtain its integer value. So we perform minus character 0 to obtain its integer value. And then we perform, we need to multiply 10 raised to 3. And the 3 is the string power. So here, in the previous iteration, we need to decrease the value of string power by 1. When we proceed to the next iteration, we need to decrease string power. And you can continue the iteration until we process all the characters. And finally, str value will be the sum of these components. So finally, str value will be 56,789. And you can download this program from our course website. You can find you can go to the reference web page and go to the C strings. Go to the strings, the test stoi. STOI is defined in the string library, and STOI implementation is our own implementation, and you can compare the results of the two functions to see whether they are the same. And we have finished the second part. We have finished the introduction to C++ string. Then we need to, then we will go to the third part. The third part is about string input-output. And for string input-output, we usually use cin. We use cin to read user inputs. One behavior of cin is that cin will skip any space or new lines until it finds the next input value. So cin will not read spaces or line breaks. When you want to read spaces or line breaks, you need to use other functions, and we will introduce these functions in this topic. And another behavior of cin is that the program does not read the input until the user press the return key. This means you can correct your mistakes by press backspace before you press the return key. You have chance to modify your inputs. Here is one example about input-output with C string. I declare two character array A and B, and I use cin to read user input and save the user input in A and B. Now suppose the user input fly space me space and so on. And when the user type fly space, then fly will be stored in A. And when the user types me space, then me will be stored in B. And then this program will print the value of A and B. So the program output is fly me. And the remaining inputs are not used because we have no more cin. So the remaining user inputs are not used. You can try this example. Now I type fly. If I made some typo, I can fix it because I haven't typed enter. So I have chance to fix my mistake. So then I type enter. After finish this line, I type enter. When you hit enter, fly is stored in A and the me is stored in B. So when you print A and B, you see the result. And we know that the space is skipped. Cin will not read the space. And if you want to read the space, you can use the getLine function. This getLine function can read the entire line, including the space. So if you want, this example shows if I enter this line, the getLine will print. The getLine will read the entire line and save the entire line in this array A. I think our time is up, so our class can dismiss.